Hi Professor, my name is Lee Hyunjun and today I will review the semiconductor 1 briefly and then I will explain what is conduction band and valence band and p-n junction and so on. First, I will review the band theory. Let's see the graph. There is atom and there is electron turning around the atoms. The electron has potential energy, which is equation like this. However, if there are two hydrogen atoms, then what happens? If two hydrogen atoms are far enough, then there is no effects to each other. However, two hydrogen atoms becomes close to each other, then the energy is strengthened and overlapped. So a diagram change like this. Then if there are many atoms, what happens? We can draw a new and different picture of energy band. This is a beginning of the band theory. Okay, now I will explain what is conduction and valence band and band gap energy. Let's see this graph. Here is valence band and here is conduction band and vacuum energy here, and forbidden band is here. What is the conduction band and valence band? The definition of conduction band is that at 0 Kelvin, the lowest energy level completely empty. Also, the definition of valence band is that at 0 Kelvin, the highest energy level fully occupied by electron. The forbidden band is between the conduction band and valence band, which has no electrons here. Then, why the definitions start with 0 Kelvin? Because thermal energy can make a generation of the pair of electrons, and holes. This is so-called electron-hole pair generation, the EHP generation. Next, let's consider the silicon crystal doped with phosphorus. This phosphorus makes the silicon crystal N-type. Let's see the diagram. Conduction band is here and valence band is here. Between the half of the conduction and valence band, there is intrinsic energy here, and because the silicon crystal is doped with phosphorus, the Fermi level moves to conduction energy. However, when the silicon crystal doped with boron, the silicon becomes p-type and the Fermi level moves to a valence band like this. Then, what is Fermi level and density of states, DOS? Fermi level is the energy level which has 50% probability of being occupied with electrons at any given time. DOS, the density of states of a system, describes the number of states per an interval of energy at each energy level available to be occupied. We can get the number of electrons by multiplying the Fermi-Dirac function and density of states. Now I will explain p-n junction. The p-n junction is joined with p-type and n-type. Let's see the band diagram of p-n junction. Here is conduction band and here is valence band. Here is a Fermi level. Because this part is n-type, so Fermi level is close to conduction band. Because this part is p-type, so Fermi level is close to a valence band. This region is called the neutral region, and the depletion region is between the natural region. This diagram looks like tails, describes the concentration of donor and acceptor. There are a lot of donor and there are a lot of acceptor. There are a little of the acceptor and also there are a little of donor. Okay, thanks for watching my lecture. Bye.